Do you recognize this? How about a closer look? If it doesn't look familiar, don't worry.
This is an unprecedented look
At this, our very own star. It's just that we're seeing it in a new light, says NASA physicist Dean Pesnell.
We're taking a full disk, extreme ultraviolet image of the sun, 8 of those every 10 seconds.
Here's a look at the sun on Tuesday. The movies are false color representations of different bands of extreme ultraviolet light. That's light produced by super hot ions in the sun, in this case mostly iron. And here's a composite image. The images come from NASA's Solar Dynamics Observatory. It was launched in February and is now perched in orbit about 93 million miles from the sun.
We're still calibrating the instrument, so right now it's more that look kind of cool type of analysis.
And there's no shortage of cool stuff to see, like this.
Coronal rain is a cool-looking phenomenon. It has something to do with how material is being put into the prominence.
That's the technical word for this thing.
So now it's falling back down to the surface of the sun.
And then there are coronal holes.
Well, coronal holes are my favorite thing. I have several students working on them. They're just black regions. The magnetic field comes out of the surface of the sun, simply leaves the sun.
And that's in contrast to a sunspot, where the magnetic field comes out and then loops back into the sun nearby. You can see the magnetic field. It's lit up here by hot plasma. Sunspots are signals that solar storms are on the horizon.
There are two kinds of solar storms. There's the flare, and that's just a bright flash of light. Most are seen in very short wavelengths, in ultraviolet and X-ray. And then there is the particle side of the storm, and there you have particles being thrown off the sun. And those are called coronal mass ejections.
This space weather is driven by the sun's magnetic field, which the observatory can also measure by looking at polarized light. Though just how magnetic field and solar storms are linked isn't well understood.
No, that's the mystery.
Solving that mystery is part of the aim of the observatory, and that's partly because
those flares and the erupting prominences that we'll later call coronal mass ejections, or CMEs, can actually come here and affect us here at the Earth. We now use GPS. That's a radio technology where you stand here on the Earth and you're talking to 4 to 5 satellites that are high above the Earth.
Solar storms can garble GPS messages by distorting the radio waves. The hope is to be able to better predict these events by forecasting solar weather. Now, it's known that the sun goes through cycles of activity. For example, every 11 years, solar storms peak.
We're in the quiet time. We call this solar minimum.
And even for a solar minimum, the solar storm activity has been unusually low.
To most people, the sun is boring at this point in time. There's not very many sunspots. The magnetic field is kind of weak.
But that's good for calibrating the instruments on the observatory. Plus, solar activity is predicted to rise, the peak for the 11-year cycle coming in 2013, which makes this a good time to start snapping pictures. For Science Friday, I'm Flora Lichtman.